The following video shows a quick demo of the use of VP-Link software for control system logic testing. Please note that this example is tested using a Rockwell Automation control system. VP-Link has drivers for various systems including Rockwell's ControlLogix, so the same approach can be used for other systems. We'll start the demo with the view of the Rockwell HMI screen. For this example, the process we will be looking at today is a simple Rockwell system with an HMI screen and one emulated controller. In order to be able to establish communication between VP-Link and the Rockwell controller, we need to extract the I/O tags from the controller and download them to the VP-Link program. This process of extraction shown in this demo is similar for other control systems. VP-Link has various extraction tools for different control systems, making it easy for users to test their various system components. For this Rockwell example, step 1 in this process is to save the ACD file as an L5X file. The demo shows the extraction program go through the process of automatically extracting the relevant data from the control system file. In this example, the demo shows the extraction program and goes through the extraction process. The resulting extracted file is a config file that can be readily opened in Microsoft Excel. The extraction process gives us the control system tags in an easy-to-read and editable Excel format. From here we can review the tags, add extra details and manipulate the parameters and algorithms. Once we are satisfied with review of the tags, we can then import them to the VP-Link server. VP-Link uses live code as the graphical user interface or GUI and imports the tags. This step involves the process of importing in an HMI screenshot. The user can then add the tags on the HMI screen and then populate the image with a representation of the process graphics. VP-Link has a powerful search feature that can search for tags based on tag names, description, or driver name or a combination thereof. Populating these tags helps to give the user a good idea of which I/O tags are important and critical to the process and can make the testing process run smoother. Objects such as valves, limit switches and pumps can be easily added and linked to the actual I/O tags to dynamically show the status. The demo shows the process of putting in parameters and linking tags to other tags. The next step shows how easy it is to add an algorithm or mathematical expression. In this case, the flow tag is defined so that it only shows flow when the pump is running and the block valve is open. Similarly, we will link the open and close limit switches to change status as the block valve is opened or closed. Now that the tags and screens have been set up, the system is now ready to connect to the controller. We achieve this by turning on the I/O and waiting for the communication to be established. While we wait for communications to be established, the user can check on the interface driver program that facilitates the communication between VP-Link and the PLC. In this case, the system is using the OPC protocol via RS links. In this example, the user tests the communication by pushing an arbitrary value in the pressure transmitter. For this example, the user can change the value to say 10. The user can then check the controller to verify that the value made it into the controller. Testing using VP-Link can be done by making ad hoc changes on the fly. We will now demonstrate some of the test compiler module features for VP-Link. The test compiler allows for rigorous testing of a user's safety and control logic. It allows for multiple scenarios that test cause and effect matrices to be quickly set up and tested, while providing documentation that can be used for test verification and proof of compliance. Testing processes can be automated to ensure efficient testing, fault identification, subsequent rectification and retesting. In addition, these scenarios or cases can also be readily executed sometime in the future, in the event change is made to the control logic. This helps demonstrate that the changes being made has not affected the integrity and function of the original control code. The typical test plans can be put together using Excel, which provides an intuitive method of setting up the scenarios. These scenarios can be used to test 2 out of 3 failures, reset procedures and trip conditions, as well as many more situations. Once the Excel sheet has been put together, the user can then use Wood's proprietary test compiler module. This then converts the Excel template into a scenario file that can be used within VP-Link. The scenarios are executed and can be monitored from the LiveCode HMI. While only one scenario is run at a time, a queue can be made that will run all of the scenarios sequentially. Between each scenario, a reset of the simulation and the control system is performed. This ensures that each scenario starts from the same baseline. Once all the scenarios have run, the user can review the documentation automatically provided by the test compiler to see what scenarios failed and what scenarios passed. For the scenarios that failed, the user can directly open the logs to investigate why and where the scenario failed. With the VP-Link test compiler function, cases can be run sequentially overnight. The test results can then be checked the following morning. This facilitates an efficient, programmatic, and auditable process of addressing any faults or failures that were identified during the logic testing. Thank you very much for watching our demo on VP-Link. To find out more about VP-Link and other solutions that we offer, please visit us on the web at Cape Software. We look forward to the opportunity to help. Stay safe, and have a good day.